Good morning, friends and dear students. I really feel overwhelmed to be in the last phase of my course, which is very favorite for me, that is aircraft systems. I am in the process of question bank and their answers of module 3, and this module 3 belongs to the topic hydraulic and pneumatic system of the aircraft. I am Dr. Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have done with my all 5 modules of lectures, followed by case studies of 15 lectures, and also definition and terminology of 5 lectures I have completed. Now I am in the last phase. Just only next 3 lectures are left for this system. Here I will be taking some questions and answer, and today I am interested in hydraulic and the pneumatic system. I will take some questions and I will discuss on that. Topics and the CO mapping, because it is very much essential that we should take this thing. So mechanical advantage of hydraulic system, classification of hydraulic system, actuation system, green and red hydraulic system of aircraft. This I am going to discuss in this lecture. So the first question is, so with diagram the mechanical advantages of hydraulic system. This is the question and how I am going to start, and this will be basics of the hydraulic system. So here we have the 2 major advantages of this hydraulic system. Ease with which force can be transmitted over large distance and into a sealed compartment. So it is ease. Keyword is ease. Ease with force can be transmitted. Next is the force. Next is the transmitted over the large distance. So these are the 4 keywords on the first point. Ease of operation of the system. So if we use the hydraulic system, a very less effort is required by the operator, and the force can be transmitted over a large distance. Small pipes are only required, and whatever distance, a very long distance, it can be transmitted without any interference in any hydraulic system. Next is large gain in mechanical advantage. Also we get large gain in mechanical advantage made possible by varying the size of the piston. So with a small diameter of the piston, and as much you increase the size of this system, that much advantage you are going to get. So here a very nice diagram I have taken from the reference. Here if you see that we have applied a force of any unit kg. Here I have put a 1 kg, and here is a piston and here is the cylinder. The area of this is 1 square inch. You have pressed this thing 1 inch here. So you are pressing here from here to here. Then what will happen here? Here is 1 inch, and here we have made a 20 inch. So this 20 inch area of this piston, and you are pressing the 1 inch, then it can lift up to 20 kilogram or 20 times of the weight which you are applying. So what is the advantage of mechanical advantage? You are going to get 20 times. However, the distance will be reverse of that. So here this 20 inch only, from here to here, this is only 1 by 20 inch. It is moved. So by a small amount of force, we can get a better advantages, and that is the very, very specific advantage of mechanical advantage which we can get by varying the area of the application of the load. So if you are applying the load 1 kg in a 1 square inch or square centimeter of area, you can lift a force up to 20 kg if the another piston and cylinder is 20 times, 50 times. Like this, you can get a huge amount of load you can lift. So that is the basic advantage. Also, it has got ease of operation, very smooth. If you have the push-pull rod and some mechanical linkages, it will give lot of sound, lot of force you have to apply, and this much advantage is very difficult to get. So that is the first and foremost benefit, or it is called the mechanical advantage. Advantages here continue. If a large amount of movement is needed, but only a small amount of force, we can use a large piston to drive a smaller one. But sometimes opposite to this, if suppose I want to shift in a long distance, so I will apply here more load and it will go 20 times, it will be lifted up. So it is another advantage. The fluid moved by the large piston will enter the cylinder with a small piston and move it a distance equal to the volume of the fluid divided by the area of the small distance. So in this example, it is 1 into 20, so 20 times. If you press 1 inch, the bigger piston, the smaller will lift to the 20 times. All hydraulic systems are essentially the same, whatever their functions. Every hydraulic system, whatever they are applicable, it is applicable to the truck, bus, your bike, scooter, or in lathe machine, or in aircraft, or in spacecraft. Everywhere the same system is used. Regardless of the application, each hydraulic system has a minimum number of components and some type of hydraulic fluids. So every aircraft has got some minimum requirement of components and some type of hydraulic fluids are there. They should have some properties that I am going to discuss, I think, in after few slides. Next, classify the hydraulic fluid characteristics. So this is the question. So what are the characteristics which we have to classify? The fluids used in aircraft hydraulic system is one of the system's most important parts. The fluid must flow with a minimum of opposition. So that is the first characteristics. The fluid which we are using in aircraft or any hydraulic system, the resistance between this should be minimum. There's between the layer and between the material or the tube and the fluid, the resistance should be minimum. Must be incompressible. Means incompressibility should be there. Means if you are pressing, it should not press. It should remain, the volume should remain constant. Good lubricating property. It should also lubricate the system. Inhibit corrosion and non-attack seals. It should be corrosion resistance. And if corrosion is also formed, it should remove it, inhibit, and not attack seal. It should not be affecting the seals. Rubber seals are there, so it should be rubber or any seal material which we are using, it should be friendly. It should not deteriorate the seals. Otherwise, every time we use the seals, and if you don't use if the fluid is not proper and it is doing some chemical reaction, so the seal will be deteriorate and leak will start. So the fluid should be in such a way that it should be very friendly with the seal material. Must not foam in operation. During high pressure and all, the foam should not be generated, otherwise it will try to extract the air, and this air is not good, and there will be a compressibility effect will be there. So it should not form bubbles, it should not form the foams at any operating pressure and the temperature. Some very important characteristics that must be considered here are the viscosity, chemical stability, flash point, and the fire point. So these are the few important characteristics. Now I am going to describe about these all four characteristics. The viscosity is the internal resistance to flow. Gasoline flows easily, has a low viscosity. Tar flows slowly, has a high viscosity. So here this we can see that if any fluid which has the low viscosity, it will flow very easily. So like petrol or gasoline, if you put in a pipe, it will go very fast. But same way, if you put a tar or grease or some thick fluid, it will go very slowly. It means the thick flow has got very high viscosity and the thin flow fluid has got a low viscosity. A satisfactory liquid for a hydraulic system must have enough body to give a good seal at pumps, valves and the pistons, but it must not be so thick that it offers excessive resistance to flow. So it should not be very thin also. If it is very thin, it will be compressible. And if it is very thick, it will not flow. So we should make somewhere in between so that it gives a better quality. The average hydraulic liquid has a low viscosity. Most of the hydraulic liquid which we use in our application, they have a low viscosity. Next is the chemical stability, is the ability of the liquid to resist oxidation and deterioration on a long period. So it should be chemical stable. It should not form the oxidation or the corrosion. Also, it should not deteriorate. Its composition of the chemical composition should not be away. It should be intact and it should have a proper quality for a long time. Excessive temperature have a great effect on the life of the liquid. So it should have, in high temperature also, it should maintain its chemical stability. Liquids may break down if exposed to air, water, salt or other impurities. So this also, it should able to sustain in a air. If it is exposed to air, water, salt or other impurities, if they are mixed also, its composition should not be distracted. Next is a flash point, is that temperature at which a liquid gives off a vapor sufficient quantity to ignite momentarily when a flame is applied. High flash point is desirable for hydraulic fluids. So flash point, it should be high. Otherwise, in the low temperature, if more vapors are generated, so there are chances of the fire. A momentarily fire, instant of time, fire will take place. And if it is propagated, it will start burning. So the flash point should be very high for hydraulic fluid. Fire point is the temperature at which a substance gives off vapor in sufficient quantity to ignite and continue to burn when exposed to a spark or a flame. So the fire point also should be very high. A high fire point is required of desirable hydraulic fluids. Demonstrate different types of hydraulic fluids. So we have mainly three types of hydraulic fluid: vegetable base, mineral base and the synthetic fluid. Vegetable base means it is extracted from the vegetables, vegetable oils like mustard oil, custard oil. These things are taken from the plants. Mineral oils are the petroleum product. Military H5606 is the most widely used hydraulic fluid in general aviation aircraft. Kerosene type petroleum product, dyed red for identification. These mineral types of red in color. So normally OM15 is one of the hydraulic fluid. It is called oil mineral 15. So this is the one name and it is military H5606 is its specification. It is in the red color. So you can identify that it is a mineral oil. Next is the synthetic fluid, non-petroleum based hydraulic fluid for use in high performance piston engine and the turbine powered aircraft. Most commonly used fluid of this type is Skydrol. This is the another type of fluid. It is a synthetic fluid colored light purple. Its color is here and color is here. So you can identify that if it is a purple, it is a synthetic fluid. If it is a red, it is a mineral fluid. So like this, you can identify. Classify the hydraulic system general purpose. So in this we have the hydraulic system, open hydraulic system and the closed hydraulic system. So this you can see there is a lake, and this lake water is raised here, and from here a turbine is fixed here, and this due to this thing a turbine will rotate and this power will be generated. So it is called the hydraulic power. Okay, this is the hydraulic power plant, and if you see here the hydraulic fluid, it is a closed one. It is for the brakes system. So you are pressing here, it will press this and this will go here, and it will press here and this shoes will be contracted, and this is called a closed loop system of the hydraulic fluid. Illustrate and explain the brake system of an aircraft. So this we can see here, these are the brake shoes, and these are attached with a hydraulic jack. So here is a tank. From here it is a piston is here. So if you are applying a force here, it will compress here. This compressor will go here. It will try to push this thing and the brake will be applied. And these are brake shoes, and this is operated by the spring. So as and when you release, this spring will again disengage. So brake on and off. As you apply this, brake will be on, because this shoes and this shoes will be intact. As and when you release it, pressure will be released and this spring will try to reopen. So like this, a hydraulic brakes are working. Most of our vehicle, even aircraft also, the hydraulic brakes are used. With suitable diagram, discuss about power packed hydraulic system. So here I have shown one power packed hydraulic system which is taken from the reference one. Here we have a reservoir here. Reservoir is a tank from where the fluid is taken. From here it goes to the pump here. Here we have the gear type of pump. Here we have the high pressure control valve. Here is a thermal relief valve here. Here we have the low pressure control valve is here. This is there. Here we have the non-return valve or shuttle valve is here. So from the reservoir, air is sucked by the pump. From here, a high pressure is going here, and this is going to in this way. Then it goes to the free fall valve here. Then from here it goes to the nose gear hydraulic cylinder. It is for the landing gear, and it is for the right main landing gears, and it is the left. This is the right, and this is the nose. So as you apply this thing, your restrictor valves are here. These restrictors valve will restrict the motion, and this will actuators will move, and your landing gears will open. So this is a very simple diagram. Here we have the pressure switch. This pressure switch will measure that how much pressure is generated, and these are the return line. Return line, and this is the yellow is your hydraulic fluid without pressure, and this is the return line. In this return line you will have the free fall control, and here we have the free fall valve. So during free fall of the system it will function. List hydraulic system components and their functions So we have the main components: reservoir, pumps, selector valves, check valves, hydraulic fuses, accumulators, and the actuators. So what is the reservoir? In an inline reservoir, space is provided in the reservoir for fluid expansion and the escape of entrapped air. Jet aircrafts that operate at altitude where there is not enough air pressure to assure a positive feed of the fluid to the pump have hydraulic reservoir pressurized. We have the different types of the pumps: gear pump, generator pump, and the vane pump. Powered pumps we can divide into two groups. Constant displacement moves a specific volume of the fluid each time its shaft turns. Variable displacement does not move a constant amount of fluid each revolution, but only the amount of the system will accept. Then we have here pumps here, different. We have the gear pump, we have the vane pump. This medium volume of the fluid under pressure, it will be able to handle a medium volume of this thing. Here we have the two gears. These gears are operating in rotating in opposite direction. From here, the inlet is from this direction, fluid will go here, and this will be trapped. And if you see here, the volume is reducing here, and this slowly it is reducing. A high pressure will enter here. And if the pressure is more than the requirement, this is the high pressure, this is a relief valve, and this will be opening, and it will be entering here. So in this way, this system is, and here also one valve is here. So if in case pressure, so it will be reverting in this direction. Next we have the vane type of pump here. So here we have, this is the rotor, here we have, these are the vanes, and these are the sleeves. So here it is entering from here, and from here it goes to the here. And if you see here, this area is increasing here, and as it is going here, area is decreasing, and the volume is decreased, and the pressure is increased. Pressure is increased due to reduction of the volume. Okay, so this is the vane type of the pump which are used in the hydraulic system. Next is illustrate and explain hydraulic fuses. So in this we have to see that what is the purpose of the fuse. You know that in electrical system we used to have old type of wire which is fixed on the near the main supply, and if the power is more than that, and it will burn 5 amperes, 8 amperes, 10 amperes, 15 amperes, like this power used to be, this wire used to be there, and as and when some short circuit is there, the amperes will go more than that, and it will burn. Nowadays we have the circuit breaker. Every house is a one lifting, and these circuit breakers are there. As and when, normally it is in up direction, and when any short circuit or any overloading is there, it will fall automatically. So it is safe. Even if high current is there, and so people may die if these things are not fitted in the house. So we have to make sure that fuses are there. Same way in hydraulic systems also, we have to make sure that as and when the system pressure is going above the required amount, if it is going above, then what will happen? There may chances of bursting of the system, pipeline may burst, leakage may be more, your seal may be damaged. To avoid that, our system should be in given limitation. So that is the purpose of the any hydraulic fuses. So flow is stopped, the pressure drop across the fuse has moved the piston over so that it covers the holes through which the fluid must flow. So this you can see in the normal case, flow is coming from here and it is entering here, and it is passing from here. But as and when the pressure is more, then there is a spring, and from here it will compress it, and it will block this passage. So there is no passage of fluid, and system is safe. So that is the purpose of the fuse here. Normal flow through the fuse, and here it is an emergency, or the high pressure is here. It will operate this valve here, and they will close this passage, and the system will be safe. So that is the purpose of the hydraulic fuse. It is acting like a electrical fuse. Next very important item is demonstrate the need of accumulators in the hydraulic system. You might have seen and you might have observed in our this water system, we use some accumulators on the piston type of systems. So if the pressure is high, these accumulators store the energy, and as and when in the system pressure is low, this will release the hydraulic fluid in a high pressure. So the objective of this accumulator is to accumulate the energy of the hydraulic fluid and amount of hydraulic fluid if it is more than the required of the system, and as and when the pressure level of the system is reduced from a given limit, this will supply the power with the hydraulic fluid so that the system is safe. So that is, in this we can have one side is the air or nitrogen, and here is the hydraulic fluid. So it is the air is charged from the bottom side and the fluid is entering from the top side. So all accumulators consist of a high strength container divided by some form of movable partition into the section. This you can see, this is the partition. This is the partition. A diaphragm is here. This you can see, this is the diaphragm, and it can move up and down. One compartment connected to hydraulic manifold. So here is the hydraulic manifold here, and other is filled with the compressed air with the nitrogen. So here is a compressed, here is what? Compressed nitrogen or air. So in this way it is functioning, and it is as a safety and emergency measures. In case your hydraulic system also failed, that time for few minutes your accumulators will work and they will give the power supply so that aircraft can land. The emergency operation can be performed by the pilot. Next is difference between single and the double acting actuator. So here single acting linear, double acting unbalanced linear, double acting balanced linear. So here we have the three types of actuators. Single acting, this you can see here, it is this one is a single acting. So in this, what will happen that the flow will come from here and it will compress this and it will go in this direction. As and when this work is completed, fluid will again go by. It is called the single acting. So this type of systems we can use in our brakes systems and all. One is the double acting. So here this is the up port and this is the down port. So if you are pressing here, it will go here and it will go in this side. So if you are compressing here, it will make up and this will go down. So in this down and this thing, it is called the double acting, and piston area minus area of the actuation rod. So here this area is less and here is area is more. So that is the in this way. In this we don't have any spring and all. By the variation of the pressure, we are trying to move, and these systems are operated accordingly. Demonstrate the hydraulic actuation system of aircraft. So how the hydraulic systems are operated of the aircraft. On military aircraft, the primary flight control actuator normally consists of two pistons in tandem on a common ram. Each piston acts within its own cylinder and is connected to a differential hydraulic system. The ram is connected at a single point to a control. The philosophy is different on civil aircraft, where each control surface is split into two or more independent parts. Each part has its own control actuator, each of which is connected to a differential hydraulic system as shown. So here the methodology of the military and the civil aircraft is different. On the military aircraft, the primary flight control actuator normally consists of two pistons. So this you can see here, this is the one piston and this is the two piston. on a common line. This is the common shaft is here. Each piston acts within its own cylinder and is connected to a different hydraulic system. So this you can see here, left hand system, and here is the right hand system. The ram is connected at a single point to a control. The philosophy of the civil aircraft, if you see, this is for the civil aircraft. So for the civil aircraft, where each control surface is split into two or more independent parts, each part has its own control actuator, each of which is connected to a different hydraulic system as shown here. So number 1 system, number 2 system, and actuators are here, control surfaces are here. So we have some two separate things. So if one is failed, another can work. So the redundancy in the civil aircraft is much more than the military aircraft. Few of these actuators are shown here for your references, and it is looking like this. So this is only for your how it looked like, and these are the hydraulic part, and they will move, and these are the bearings. This is the hydraulic jacks, and here we have the electro-hydraulic actuator system. It is from the Dunlop. The company name is Dunlop. Here it is shown. So next, illustrate the working principle of a hydraulic pump. So here this you can see here that it is a piston type of pump here. So if you see here you have the cylinder block. Here is a fluid return, a fluid outlet. So fluid it is going like this, and here it is compressing. So it is a elliptical and it is eccentric. So it is called the stress plate, and this will move like this, like this, like this. Due to this, the piston will move up and down, up and down, up and down, and if it is feedback is given as per this spring. So when the plate is at 90 degree to the linear axis, there is no linear displacement of the piston. Up to its maximum limit, the plate will move to displace the volume needed to maintain nominal system pressure. When flow demands beyond maximum displacements are made, the system pressure drops rapidly to zero. For short period, pressure can be maintained by means of an accumulator. So this, for short period, the accumulator is there, and accumulator will maintain a sufficient amount of pressure. So that is the working principle of any hydraulic system. Next, so a simple hydraulic systems and explain its working. So here I am explaining starting from here the reservoir. This reservoir is here. From here the hydraulic fluid is filled. This hydraulic reservoir is not like a bottle. There is so many baffles, so many plates are there, so many holes are there. So a small amount, it's not slash. So it goes from here to the pump. The pump may be the gearbox, gear type or piston type or vent type as per the requirement of the system. From here it goes to a filter. From this filter, any contamination, dust, sand or any other water and all are extracted from here. Then it goes to a check valve. In this only one side pressure is maintained. Then it goes to a shut off valve. From here on off it is done. From here it goes to the pressure reducing valve. Here the pressure is reduced. From here it goes to the actuator. Before going to the actuator, it will go to the selector valve. In a selector valve, it will be selecting the left motion or the right motion. And there is an accumulator, and this accumulator, as and when the pressure of this thing is going more, it will go here. And if the pressure is less here, it will supply this side. So these actuators are operated, and then it goes to the return line. This is the return line. From here it goes to here. So it will start from here. It goes here. It goes here. It goes here. It goes here. And from this accumulator, here is the nitrogen or air in high pressure, and here is the hydraulic fluid. In this way it is working, and this is the basic principle of this hydraulic system. Summarize the warning and status of the hydraulics system. So there are several instruments are fitted to ensure performance of the hydraulic system. They are the pressure transducer, monitor the system pressure and transmit this signal to gauges in the cockpit. Pressure switches are also incorporated to provide a warning of low pressure in the system on the central warning panel. Filter blockage indicators show the condition of the filter elements to ground servicing personnel, and a fluid temperature warning may be given to air crew. Use of the microprocessor based system management units. More in-depth health monitoring of all major components is possible with a data displayed to ground crew on a maintenance data panel. So warning systems, we have the pressure transducer. So if it is high pressure or the low pressure, it will be indicated on the warning panel or the cockpit of the aircraft. Pressure switches are there. These pressure switches will make sure that it is cut off. Just now pressure, this hydraulic fuses are there. If the pressure is more than that, it will stop. Nowadays we use the microprocessor based, computer based system. In that it will monitor also, and it will also give the data, and also it will try to rectify the problem as and when it is raising more than the limits. Demonstrate the emergency power sources in an airplane. So I have discussed about accumulator in detail. So accumulators are the devices in which the high pressure air is or nitrogen is charged in half of the portion, and another part is filled with the hydraulic fluid. As and when the power supply is fluctuating or it is not giving a proper supply, it will give. So gives emergency supply for canopy, wheel brakes, flight control systems. So these are the few very important part for which hydraulic fluid is required, and it is supplied by accumulator. To supply emergency power for longer period, an electric motor driven pump may be provided. Battery size and the weight are the main limitation in this case, and to minimize these factors, the flow available is usually kept as low as possible to operate only those devices considered indispensable. Weight may be kept to a minimum by the use of the one-shot battery. Weight may be kept a minimum by the use of one-shot battery. Hydraulic pump and the emergency electrical generators can be mounted immediately behind the turbine on the same shaft. So this is the motor, electrical motor driven, because this accumulator will work only for few minutes. But if you want for more time, then we need some electrical motor driven pump, and this power has to come from the proper generator, and this pump has to operate separately. Next is the illustrate and explain the function of the yellow and the green hydraulic system. So what is the yellow and what is the green hydraulic system, that we have to understand, and that we have to imply. So the systems are designated yellow and the green and are normally pressurized by a self-regulating engine-driven pump on the inboard engine. Each system has an independent hydraulic reservoir pressurized by the regulated air bleed from air respective engine. The yellow system is on the left of the aircraft and the green on the right. Backup power for the yellow system is provided by an AC electric pump, and backup for the power of the green system is provided by a power transfer unit. So for the yellow system it is electrical pump, and for the green system it is a PTU driven by the yellow system. An electrically operated DC pump fed from a segregate hydraulic supply provides emergency lowering of the landing gear and operates of the brakes in the event of failure in both the yellow and the green system. So if both system yellow and greens are failed, then electrically operated DC pump fed from a segregated hydraulic supply provides emergency lowering of the landing gear and operating of the brakes in the event of failure in both yellow and the green surfaces. The primary power generation components of the yellows are engine driven pump on number 2 engine, standby aircraft powered hydraulic system, emergency DC powered hydraulic pump, accumulator and the reservoir. These are the emergency for the yellow system. For the green system, the yellow systems power the following services. One flap motor, flap asymmetry brakes, roll spoilers, two lift spoilers, one rudder servo control, standby fuel pump left and right, landing gear emergency lockdown, wheel brake including parking brake, air steer through the AC pump, power transfer unit. These systems are operated by the yellow power system. So yellow system components in the hydraulic bay, it is shown here. This you can see here, a very big room is there. These are the accumulators. And these all pipelines, pumps, these all things are here. And this is the technician who is working here. So yellow system emergencies. So what are the yellow systems emergency? So in this we have the backup DC pump. So yellow system reservoirs, the reservoirs incorporate the following: a pressure gauge, a side glass, an air low pressure switch, inward and outward relief valve, a bursting disc to protect against manual failure of the outward relief valve, a ground charge connection and manual pressure release lever, a content transmitter. So these are the emergency yellow will have. So engine driven pump, the yellow system engine driven pump is mounted on the left inner engine auxiliary gearbox at the bottom of the engine to ensure easy maintenance. It has motorized isolation valve. When the valve is closed, it isolates the pump from the tank and provides an idling circuit to offload the pump. If the engine fire handles it pulled to its fullest extent, the valve closes automatically, preventing more fluid reaching the pump. If you talk about the green system, the primary power generation component of the green systems are engine driven pump on number 3 engine, power transfer unit, hydraulic reservoir, accumulator. All components except for the EDP are located in the hydraulic equipment bay, which I have shown you. This is the hydraulic equipment bay. This one is the hydraulic equipment bay. So these all are fitted in the hydraulic equipment bay. Green systems power the following. So flap motor, 4 lift spoilers, air brakes, landing gears normal, nose gear steering, wheel brakes excluding parking brake. These are the systems operated by the green system. So here I am ending my today's lecture. If any questions, you are welcome to ask. Okay, so you can ask ydwvedhi@gmail.com, and please like and subscribe this channel. Thank you very much for joining my class. Okay, we will see again for my next lectures.
Like, share and subscribe. Hit the bell icon for more updates.